Caligus epidemicus has been reported to occur in salinities of 2 to 32 ppt. Another important sea lice species in the region is Caligus rotundi genitalis. Okay, Table 13 shows the reported host species of Rotundi genitalis in the region, belonging to 2 orders and 6 families, causing significant mortalities in sea bass, snappers, and hybrid grouper in Malaysia. In Taiwan, Caligus rotundi genitalis has also been reported from 33 fish species belonging to 19 families. So this indicates that Caligus rotundi genitalis has low host specificity. In cage-cultured crimson snapper and emperor snapper in Penang, Malaysia, sea lice-infected fish showed hemorrhages on the caudal fin. Areas on the body are devoid of scales with associated mortality. Large numbers of Caligus rotunditinalis with a small number of Caligus epidemicus were observed, with a prevalence of 81% and a mean intensity of 5.6. Infection was observed in salinities of 19 to 32 ppt in Indonesia and 25 to 28 ppt in Malaysia. Next is Lepidopterus spinifer. In our 2011 paper, we reported marketable sized pompano exhibited extensive skin lesions, thereby considerably reducing its commercial value. Affected pompano had 100% prevalence of Lepidopterus spinifer with an estimated intensity of 50. At the Igang Marine Station of Siftec in Guimaras in the Philippines, L. spinifer infection perennially occurs on the body surface, fins, and eyes of the pompano breeders. We looked at the seasonal population dynamics of L. spinifer infecting the pompano breeders by daily measurements of the water temperature and salinity from the infected cage from September 2018 to May 2019, covering the warm season, which is from March to October, and the cold season from November to February. Water temperature at 29 degrees to 29.4 degrees centigrade in September to early November are not significantly different. Temperature starts to drop in mid-November and significantly lowest at 27.5 degrees centigrade in January to mid-February, and starts to increase again in March and significantly highest at 30 degrees centigrade in April and May. Mean water salinity ranges from 30.5 to 32.5 ppt in September to December, and significantly highest at 34.5 to 35 ppt from January to early March, and then significantly drops from mid-March at 33 ppt to May at 30.5 ppt. Population of L. spinifer maintain 100% prevalence throughout warm and cold seasons. However, mean intensity increased only during the cold months, which is from early November to early March, with the highest mean intensity in early January at 200 at a temperature of 27.5 degrees centigrade and a salinity of 35 ppt, while the lowest mean intensity was recorded during the warm months, dipping into 12.5 in early May at a temperature of 30.5 degrees centigrade and a salinity of 30 ppt. Our result is in contrast with previous studies on the seasonality of caligid populations in temperate regions, wherein mean intensity generally peaks around the warm period of the year. Whether this observed seasonality is uniquely exhibited by Leopteris spinifer or is also shared by other sea lice in tropical environment require further studies. Prevalence of adult males and adult females was high throughout the monitoring period. Pre-adults also had high prevalence, except at the start of summer in late March to early May. Chalimay stages were observed only during the cold months, specifically from early November to late January, with prevalence of 40 to 80%. Highest mean intensity was in early November, which coincided with the first peak of the total L. spinifer population. This indicates that while adult male and adult female spinifer are present throughout the year, active and successful reproduction only occurs at certain period of the year, especially during the cold season. Table 14 shows the recorded host fish species and distribution of L. spinifer. It appears that L. spinifer is highly host-specific to Carangidae, including queenfish and pompano. It has been reported in Sri Lanka, India, Australia, and the Philippines. It has caused severe skin damage on wild-caught queenfish, as well as in farm-reared pompano, thereby considerably reducing its market value. During high L. spinifer infestation, severely affected fish showed hemorrhagic areas, particularly on the eyes and the operculum. Some exhibit exophthalmia and thus are blind either on one eye or both. Vibrio harbei was isolated from the exophthalmic eyes of spinifer-infected pompano broodstocks, and the authors attributed exophthalmia and Vibrio harbei infection in host fish as initiated by L. spinifer. The next is Caligus minimus. Caligus minimus infection has resulted to high mortality in farmed sea bass, crimson snapper, and hybrid grouper in Malaysia. It has also been observed in at least 5 host species caught from the wild. C. minimus has been reported in 3 orders and 8 families, indicating its low host specificity. The life cycle of Caligus minimus from sea bass is completed in 5.5 to 7 days at 30 degrees centigrade and 25 ppt, indicating a short life cycle. Recently, juvenile hybrid groupers in Perak, Malaysia, experienced high mortalities. Fish were very thin and not feeding. Within the buccal cavity of the affected fish were large numbers of reddish nodule-like outgrowths. The nodules contain large numbers of encapsulated Chalima stages of Caligus minimus. Okay, last is the Pseudocaligus uniartus. Pseudocaligus uniartus has been recorded on mangrove snapper and siganid in the Philippines. It has caused high to mass mortality among breeders of siganids in South Sulawesi, Indonesia. Heavily infected fish showed extensive lesions on skin and eroded fins, and large numbers of Chalima stage of Pseudocaligus uniartus were attached on siganid fins. The attachment and feeding sites of the Chalima stages showed inflammatory cells. The life cycle of Pseudocaligus uniartus was reported to be completed in 7 to 10 days at 27 to 29 degrees centigrade and a salinity of 34 to 35 ppt. Ho in 2000 listed 9 species of sea lice to have caused mortalities among non-salmonid fish in Asia. This includes Caligus acanthopagri, Epidemicus orientalis, Patulus punctatus, Rotundi genitalis, Caligus spinosus, Lepropterus longiventris, and Lepropterus paralictidis. Among these 9 species, 3 species, Caligus epidemicus, Patulus, and Rotundi genitalis, have caused mortalities among farmed fishes in the Southeast Asian region. To update this list based on the data presented, 3 additional species are recognized: Leptopterus spinifer, Pseudocaligus uniartus, and Caligus minimus, to have caused significant mortalities in farmed marine fishes in the Southeast Asian region. Various treatment methods have been tried to control sea lice infection, but it remains a problem. Early efforts to control Caligus patulus on milkfish breeders used Negvon, a trichloroform, but the compound renders potential risks to both the handler and environment. Short bath treatments of formalin, potassium permanganate, hydrogen peroxide, neem oil, as well as oral treatment with imamectin benzoate have been reported to control various species of Caligus. Manipulation of alkalinity of the culture water have also been tried to control Caligus minimus infection on Lattes calcarifer. Freshwater baths are regularly and repeatedly employed at fish farms for control of sea lice, but it is very difficult to completely eliminate the parasite as reinfection occurs soon. Treatment and handling of fish puts additional stress on the infected fish, and bath treatments are efficacious on parasites attached on body surface, but not on those in the buccal cavity. In Indonesia, water at the surface layer of breeding facilities are removed as developmental stages of sea lice are attracted to light. Okay, here's a list of what I believe are needed for research. In the region, reports on sea lice are generally limited to description of sea lice occurrence, while in-depth studies on the ecology of this species are scarce. Thus, studies on population dynamics of sea lice at different culture systems, and controlled studies to determine the impact of water temperature on the growth and reproduction of sea lice are needed. Pathology or the impact of sea lice on the fish host is also needed. Much work on efficient measures of control and treatment against infection are still wanting. And although sea lice pose a high threat to the development of cage farming in the region, ironically, there are only a handful of specialists in Southeast Asia working on sea lice. In the Philippines, fish parasitologists have either retired or have passed away. This shortage of sea lice specialists must be overcome if marine cage aquaculture in the region is to be developed into a large-scale operation. To summarize, about 42 sea lice species have been recorded among farmed, reared, and wild-caught fishes in the Southeast Asian region. Globally, this represents about 10% only of the known sea lice species. Among these, Caligus epidemicus is the most dangerous species. Caligus rotunginalis, Caligus minimus, Caligus uniartus, and or Pseudocaligus uniartus, and Leptopterus spinifer are potential threats in marine aquaculture in the region. A number of control and treatment measures have been explored, but sea lice infection remain a problem. Chemotherapy should not be used alone, but should be a part of an integrated health management strategy. Studies on the ecology, pathology, and control of sea lice infection are warranted. And fish parasitologists specializing on parasitic copepods are needed. I'd like to take this opportunity to thank the organizers of the fourth ISMFR 2021, headed by Dr. Inda and University Gajah Mada, Dr. Leong Tak Seng of Malaysia, Ms. Isti Sugama and Dr. Hilalar Anshari of Indonesia, and Dr. Kowa from Vietnam for their assistance in acquiring the important literatures as well as photographs. And Peter Palma and Daryl Superior of CIFTEC for some photographs and also the important literatures. Okay, thank you.
Thank you very much, Professor Erlinda, for interesting presentation about the comprehensive scientific information about the sea lice, which is one of the important parasite that impacting the aquaculture, specifically in mariculture and wild-caught fish in Southeast Asian region. We will have a further discussion with Professor Erlinda in the question and answer session after the presentation. Thank you, Professor Erlinda.
Thank you also.
Let we proceed to the next speakers, the last but not least, and a very important and interesting topics. Also about the economic value, increasing economic value from the seafood waste. So I would like to invite Professor Sutawat Benjekut for the presentation. Time is yours, Professor.
Thank you, Dr. Inda.
I'm sorry, can the committee, okay. Please, Dr. Sutawat.
Hey, Tata. I cannot extend.ให้มันใหญ่การตรวจข้างบนผมต้องชื่อเข้าใช้เอ้าอะไรไม่ใช่สิ sorry โอเค
ในแค่นี้อ่ะ
Probably the slideshow
Is
button.
full screen? You
Not-
can see the full screen?
Not
Okay.
yet.
All right. Okay.
Okay. It's
Sorry.
okay now.
Okay. All right. Thank you, Dr. Inder, and also good morning, ladies and gentlemen. So it's my pleasure and honor to be the speaker for the plenary session. For my talk today, it hydrolyzed collagen from fish skin, with emphasis on the quality improvement and in nutraceutical properties. Actually, the fish and fish product has become very important income generator for Thailand and also Indonesia. And during fish processing, a large amount of the byproducts or leftover are generated, like a head or skin or bone, for example. And for fillet production, this skin is implemented either by machine or by hand, and the skin is generated, and skin has been used as a snack, for example, by deep frying, or in you can see this kind of product is mean the deep fried skin coated with the salted egg, which is popular in Singapore and Malaysia. And to increase the value of the skin, we can produce the collagen from the fish skin with a higher market value. So what is collagen? So collagen is a protein consists of three alpha chain who narrow each other. We call tropocollagen, and each alpha chain have molecular weight around 100,000. So totally the tropocollagen have molecular weight around 300,000. And along the chain of the alpha chain, they have the glycine every third position, except there are 14 amino acids from N terminal and 10 amino acids from C terminals. So I would say that the glycine constitutes around 1/3 of the collagens. And collagen also consists of the amino acid, especially hydrolycology. And the source and where we can produce for collagen. So collagen can produce from the fish skin, scale, bone, or even swim bladders. And for this my talk today, I'm gonna focus on the ASEAN sea bass, because the ASEAN sea bass is have a lot of farm in Lake of Songkhla close to my university, and also ASEAN sea bass are very popular species in ASEAN, Southeast Asian countries. So actually, collagen can be extracted by acid solution, especially acetic acid at low temperature. However, the collagen obtained have the low yield, so pepsin have been applied. What happens is we have pepsin. So pepsin specifically clip at telepeptide region here. You can see that. So topocollagen normally like link together and form the fibrils. And when we cut these regions, those topocollagen can be leached out easily, as you see here. And that's why we can end up with a higher yield when applied for pepsin. And normally the native collagen is a Taiwan collagen. But, we have actually 28 type of collagen, but basically the collagen from skin or scale is Taiwan collagen. But based on the processing, as I mentioned, we can classify as an acid-soluble collagen or pepsin-soluble collagen or PSC. And when we take a look from the solubility, both ASC and PSC have the high solubility in acidic pH range and the lost the solubility in the neutral pH range or alkali pH range. So this is typical for collagens. And that's why the native collagen is have several kind of disadvantages. The first one is like have the lower absorption in body after intake. That because the large molecular weight. And also it's insoluble at neutral pH. And of course, it's difficult for you to fortify native collagen in the drink, like a milk, because it's not soluble and it precipitates out. Okay, and the other one is if you want to produce native collagen, you have to conduct the extraction process at low temperature, like 4 degrees Celsius, to avoid denaturation of native protein, native collagen, triple helix. So that's why hydrolyzed collagen has drawn attention from both a producer and consumer. That's because it's water soluble in nature, and also they have the higher bioactivities, which I'm going to talk more today. And when you take a global fish oil collagen peptide market, it was estimated to be $250 million in 2021. And the industry is further expected to grow at 8.2% during 2021 to 2026. I mean, around 5 to 6 years from now. And a global fish collagen peptide market can be divided in the different segments. You can see that the largest segment, more than 50%, is going to bone and joint health. Because the people know right now that, okay, if you take this collagen as supplement, they can have the better bone strength, and also joint is good, better. And also they can use for nutraceutical, cosmeceutical, and also pharmaceutical. And in fact, for fortification, which I think, I'm not sure in Indonesia, but in Thailand is the drink or some product fortified with hydrolycology is very popular. Basically, these hydrolycology produced from the fish scale or oosin. Oosin is kind of demineralized scale, but the problem is the lower yield, but the advantage is no fishy odor. That's why they prefer to produce the hydrolyzed collagen from fish scale rather than fish skin. So how about fish skin? Because I mentioned that it's a byproducts. So what we have to consider when we use the fish skin as a raw material for production of hydrolyzed collagen, one thing that we have to focus is in the fish, the fat distributed in the fish skin, and this fat contribute directly to fishy odor of resulting hydrolysis. You can take a look from here. You can see this is kind of like the images of the fat distributed throughout the skin. We stain with the 9 blue A and using confocal electron microscope. You can see the red dot here is represent the fat distributed throughout the skin. And also the skin of the sea bass, Asian sea bass, they rich in the PUFA. You can see from here that among all, they have the constitute around 41.5%. And also they have the EPA and DHA at high content when compared with other fatty acids. So this means that these one with the fish skin have the high PUFA, they prone to oxidation. So what happens is in the present oxygen that can undergo the propagation, initiation propagation, and they form hydroperoxide. And hydroperoxide is not stable and decomposed to be lipid oxidation products. This causes a fishy odor. And how to improve the, if we want to use a fish skin, how we can improve the product, I mean, hydrolyzed collagens. The first thing we have to consider is to improve the defatting process. So today I'm going to talk about what we have developed in our center. So we use lipid together with polyelectric field and vacuum impregnation. So this is a vessel that we use. First, we have the tank like this, and we have a vacuum system. And you can see from cartoon here, we have the fish skin. And fish skin, firstly, we have to treat it with PF, polyelectric field, and with the electroporation, so make the pore, small pore in the skin. And when we apply the vacuum, those kind of air is sucked out from the skin. And when we release the vacuum, those lipase can pass through into the skin effectively, and be done for 4 cycles to ensure that the lipase get into the skin effectively. And why? Because we want lipase to hydrolyze the fat inside the skin, right? So this is the micrograph, confocal laser scanning micrograph images. And you can see the control one without any treatment. And this is the skin that after treatment by our process, you can see that very negligible fat retained in the skin. And also when we produce a hydrolyzed, stand for SC, using the skin that we select, we develop the treatment. I mean, using PF together with vacuum impregnation with the lipase. You can see most of the volatile compound is become less, especially for hexanol, which contribute to the hexanol. And this one, the control one, you can see abundance of a lot of the compound, volatile compound, including aldehyde, ketone, alcohol, those things that contribute to fishy odor. But however, if we compare with when we use the isopropanol as a solvent, anyway, when compared with the two columns, the one that we develop using lipase have the less abundance of the volatile compound. So the result indicating that the process we developed is successfully remove the volatile compound from the hydrolysis products. And we also confirm by sensory evaluation. You can see the red bar here that the hydrolysis produced from the skin with our process developed in the center. You can see here the fishy odor and fishy flavor that the red bar have the lowest the fishy odor intensity and also fishy flavor intensity. So this confirm that the hydrolycologens have the lower fishy odor when compared with without any treatment, I mean controlling back bar. And what is hydrolycologen? Basically, you can remember that it's a triple helix, it's native collagen. And after hydrolysis by your enzyme gonna cleave the peptide bond here, and then will come up with a top chain peptide. And actually, they have the the very low molecular weight here. And they have, of course, they have high digestibility. That because we have a small molecule, and also absorb easily when after intake, and they can pass go through of the body by blood circulation. And how to produce the hydrolycologen? So actually, we have to pre-treat the raw material, I mean, skin. And most important thing that we have to defat this, remove the fat as much as possible. And then we select the hydrolysis process. For example, we can use one-step hydrolysis process, two-step hydrolysis process, like this, for example. And also we can select the enzyme type that we can use. And then we end up with the hydrolycologen with different peptide. And this example that we produce, we use the fish sea bass skin, as a raw material, and we conduct hydrolysis, and we can use from a reactor as well. And this is a sample of the hydrolysis after we hydrolyze from the pieces like this to be liquefied like this one. And the factor affecting bioactivities, of course, when we talk about the hydrolycologen, we expect for their bioactivities. So the factor determining the bioactivity include the processes used, type of enzyme used, enzyme concentration, and also these lead to the different type of peptide in the hydrolycologen. And of course, they can affect the bioactivities of the hydrolycologens. And this is example that I'm gonna talk. This is a process. We have 5 processes. You see that we use alkylase at the 0.2 unit per gram and hydrolyze for 1.5 hours. And this you use the higher level, 0.3 unit per gram, and use a hydrolyze for 1.5 hours. And this one we use parpane. This we use parpane together with alkylase. We use parpane with alkylase at higher level of enzyme. And you can see from here the fifth one, this one, they show the higher antioxidant activity as assayed by ABTH radical scavenging activity and also DPPH radical scavenging activity. You can see the highest, and also high in the ascorbic acid, here. Okay, and this confirmed that the process used to determine the bioactivity activity. In this case, I'm talking about the antioxidant activities. And from the hydrolysis that we selected, we use the mass spectrum, multi-top mass spectrometers, and we found that the peptide have a rate around 800 and also 1,100 Daltons, which is quite small one. And when we take a look from the amino profile, we can see that they also contain, you can see from here, a glycine constitute around 1/3. As I mentioned, that is similar to mother collagens. And also they contain the high hydrophobic amino acid, which may be associated with the high antioxidant activities. And this also with our study, we published in the 2017, we characterize, identify the peptide and synthesize the peptide. And you can see from here that each peptide, they have the glycine every 3rd position. You can see every 3rd position you could be found glycine as mentioned previously. So this confirmed that it's a form collagen. And different a peptide, they're going to have different activity. For example, for the first peptide, glycine, leucine, phenylalanine, alanine, glycine, proline, arginine, they're going to have the highest ABTS radical activities. And this is also an example for another skin we call unicorn-related skin. This is skin, and this is how they look like. They have the like chymety. So mostly they fillet and export. And you can see from here, by using LC-MS, we found that they have the different peptide. Again, they have the glycine every third position. And since we use glycine endopeptidase from papaya latex, glycine endopeptidase means they prefer to hydrolyze the glycine at carboxyl group. And then you can see that at the end of the C terminal, they have the glycine here. And when we talk about the bioactivity of the hydrolycologen, so the first one we can talk is the prevention of the DNA damage. So in the presence of oxidant like hydrogen peroxide supposing in our body, so in the presence of hydrogen peroxide, you can see that they have the high damage of DNA, the black bar here, and the higher level of hydrogen peroxide, like 60 micromolar, the higher damage was found. However, when we add the hydrolycologen, you can see the damage of the DNA decrease in the dose-dependent manner for both 40 and 60 micromolar of hydrogen peroxide. While the control, they have the very negligible DNA damages. So this confirms that hydrolycologen can reduce the DNA damages induced by oxidants. How about skin nourishment? Skin nourishment is very important for the everyone, because everyone want to have like look younger, you know. So I think no one want this one, right? Wrinkle, deep line like this. So can hydrogen be of help or help you to just like have the lower wrinkle like this? So actually the hydrolycologen have dual action mechanism. So they can serve as building block for formation of collagens. And also they act as the ligand, the binding to fibroblast receptors, you know. So the fibroblast is kite cell to produce the skin cell. So that's why they can function to boost the formation of fibroblast cell. Okay, so this is one study. They use the 4-week-old male white star rat. They fed the rat with the diet for 3 groups. The first one, control one, standard diet. The other one, they supplement with the 12% casein. And the last one, they supplement with 12% hydrolycologen. And after 4 weeks, the rat was sacrificed and the skin was extracted for protein. And protein was subject to different assays. And this one, they used immunoblotting assay. And you can see from here that the last group that fed with the diet containing 12%, they have the larger band of type 1 and type 4 collagen. And I want to say, explain a bit more that between type 1 and type 4 collagen. Actually, type 4 collagen is the local investment of the skin. Degradation of type 4 collagen is caused the deep line or wrinkles like this. And also when we take the test for the inhibitory activities of the hydrolycologens, so they found that the sample, the rat fed with diet containing hydrolycologen, they have the lower metalloproteases. So it means that they have the lower degradation of type 4 collagen. They use actual staining technique for this. Okay, and we also like to try to increase activities of the collagen to induce proliferation of fibroblast cell related with skin nourishment. So you can see from here that only hydrolycologen, they can increase the proliferation of cell in a dose-dependent manners. However, if we mix hydrolycologen with vitamin C or ascorbic acid 2-to-1 ratio, you can see that the highest cell proliferation can be observed. And proliferation is in the dose-dependent manners. Also, when we measure the collagen produced in the cell, you can see from here, when we use the hydrolycologen together with the vitamin C at 2-to-1 ratio, the highest collagen can be produced, and also it's in the dose-dependent manners. So that why it's no doubt that in the market, you can see this kind of product hydrolycologen plus vitamin C. And because they can help synergistically to produce or promote the proliferation of the fibroblast cell. And next, I'm going to talk about wound healing. So we use the one in vitro scratch assay using fibroblast cell. So we see that the cell first and then scratch using the sterile tip. You can see the scratch here. In the first hours, you can see here, the scratch here. And after 24 hours, in the presence of hydrolycollagen with different levels here, up to the 500 microgram per milliliters. You can see after 24 hours, the one that treated with the hydrolycollagen, you can see the smaller gap. And to be easy for you, you can see that the wound gap is slightly lower. However, the proliferation of fibroblast cell increased significantly here. You see, so this is why it's indicating that the hydrolycollagen can enhance the wound healing. And to confirm that, why this side gap, can merge together. So we monitor lamellipodium formation in the fibroblast cell. What is a lamellipodium? So it's a branch actin filament used for cell migration. You can see like this here. It's like chlorine. And then when we monitoring, we found that at the 250 and 500 microgram per milliliters, the lamellipodium is the highest when compared with the control one without addition of the collagens. All right, so to move to osteogenesis, it means related with bone. So osteoporosis is one of the problems, and World Health Organization has defined osteoporosis as decrease in bone mass by 50% and bone quality by 50%. And 1 in 3 women or 1 in 5 men over 50, more than 50 years old, will experience osteoporosis. Basically, the women have the more problem when compared with the men. And before testing, we use osteoblast cells, and we have to check the toxicity. That we found that in the range of 50 to 800 microgram per milliliters, they have no toxicity to the cell. So we move on. So here we monitor the osteogenesis, by using alkaline phosphatase, and you can observe here at the day 7 when the cell was treated with hydrolycollagen at 100 microgram per milliliters. You can see the highest alkaline phosphatase activities. So this indicating that, and also you can see from here, the highest intensity. We use a BCI-TP NBT solution to stain for alkaline phosphatase. And for 14 day and 21 day, you not see much different. So this indicating clearly that this collagen is play a major role in the early stage of the osteogenesis, okay? And also to confirm that it can differentiate or produce the calcium in the cell or not, we also monitor the cell, differentiation of the calcium in the cell. So after 21 days, you can see that those kind of calcium nodules, you can see the small dot here is like calcium nodules, is produced more in the percent of the hydrolycollagen 100 and 200. You can see from here. And this is a graph, you can see more clearly. And you can see that the 120 or 200 microgram milliliters, they can promote the cell mineralization or calcium differentiation, okay, in the cell. This is like the way they can test that. Okay, so now you get some more idea about the bioactivity of hydrolycollagen, basically on the skin nourishment, also bone strengthening or joint health. So now, because actually they have the drawback of hydrocollagen because they still have the fish odor and also the brown color somehow. So they limit application. So we end up with one technology, we use the liposome. The liposome is a bilayers, produce is kind of colloidal structure and have bilayer, and we can load those kind of target product. In this case, we load the hydrocollagens, and we use the to produce liposome. They have several kind of method, but this is the one method we call ethanol injection method. We start from the using raw material. So we use a soy lecithin, phospholipid together with cholesterol as a structure makers, and we mix with and of course they dissolve in ethanol. We mix hydrocollagen here and stir, mix together, and then evaporate ethanol using rotary evaporators, ending up with a liposome, and we freeze dry it. And you can see from here, this is a liposome we obtained and loaded with the different level of hydrolycollagen. And this is a freeze dry form. Okay, and we've monitored the size of the particle, and you can see from the liquid form is have the nano size. I mean, around 67 to 22 nanometers. And for the powder one, of course, during freeze drying, aggregation take place, so they have the larger in size. And for theta potential that indicating the charge of the liposome, we found that or they have the negative charge. That's because the phosphate group of the liposome, right? Because we use a phospholipid. So phospholipid is going to have the content of a phosphate group, they have the negative charge. And this is from the micrograph. We can see here that we use SEM and TM. And TM, you can see that they have like by layers, vesicle. So inside they load that with the hydrolycollagens like this, like a tunely here. So this one is hydrolycollagen, and the same thing here, and like have the hydrolycollagen inside. And for the dry one, we used to, you know, like a vesicle and protection the hydrolycollagen from the harsh environment. And we store for, you know, 6 months at 30 degrees Celsius, I mean, room temperature. And you monitor the activities, ABTS radical scavenging activity and DPS radical scavenging activities. You can see that the only slightly decreased throughout the 6 months of storage, but for all the samples, okay. And the last part, we're gonna talk about the application. So basically, you know, this is an example. This is a product available in the market. They license our, you know, like a patent from our center and produce this kind of products, collagen drink, and these are from other company. Okay, so and also you can see that this kind of common thing right now that the people just like take one or couple spoon, you know, in the tea or, you know, the coffee or even drink, you know, just to supplement for the collagen. And this example that we did, you know, we prepared the chrysanthemum drink, and then we start from flowers, extracting by using hot water for 3 minutes, and now we mixtures. Add sugar to make sweet, filter, and add hydrolycollagen and bottlings, tap, and then sterilize use at the 121 degrees Celsius for 11 minutes, or we say that F0 is 7 minutes, cool down, and end up with the drink. And this is the way they look, you know. This is as a function of the time, 1 month, 3 months, 6 months, you can see a bit darker. And also when you add more hydrolycollagen, we also get a bit like a darker in colors, okay? And we monitor the antioxidant activities, ABTS radical scavenging activity, DPS radical scavenging activity, FRAP, also ORAC. And you can see from here, at the first day, the one without hydrolycollagen additions, they have the lower activities. When we add hydrolycollagen to the high level, antioxidant is increased in dose-dependent manner for all SAUs. You can see here. But however, with the function of time, when we keep for 6 months, the gradual decrease in the activities was for all sample, for all the SAUs. Okay. And this pH, no change much in pH was found for all sample. However, one interesting thing that we found that the lower in alpha amino group. So you can see for all sample that because they can undergo Maillard reaction, because the free amino group in the peptide can undergo Maillard reaction with other component in the drink. And that's why they cause darker in color as well. All right, this is almost the last slide that cosmeceutical. So we also work together with the faculty member from pharmaceutical science faculty, and we develop this kind of lotion, serum, cream. Yeah. So this is just the last slide that we have volunteers, 30 volunteers to apply the serum for week 0 and week 4. You can see that after week 4, the pore is kind of much lower for this lady. You can see the forehead, the dot represent the pore. Is much lower, and also this one also lowers. And this lady also, you see that the dot is kind of lower. Okay, so that's why we're still working on this one. All right, so I want to end up with my summary that fish skin, a byproduct from fish processing, should be fully utilized to increase the revenue for the processor. and new value-added product, particularly nutraceutical and cosmeceutical with higher value must be further developed that enhances the exploitation of its skin. So thank you very much for attention. Thank you.
Thank you very much, Professor Sutawat, for your interesting presentation. We have seen from his presentation about the technology to overcome the fishy odor of the hydrolyzed collagen, and also their function in promoting the health of skin and bone, which is very important for women, I think, Professor Sutawat, and also the application in the product. Thank you very much. So, ladies and gentlemen, now we come to the question and answer session, which I'm sure that it is what are you waiting for to discuss with all the speakers. Now, let me give this opportunity first to the question that is delivered to Professor Rashid. I see several questions has been typed in the comment column, and also some of them is already responded by Professor Rashid, but let me summarize the question for Professor Rashid. So question from Ms. Rati, which is has the bigger impact between the threat of pollution or climate change or the improper policy to the ocean economic. And also the second question is about the uninterested investment for the ocean sustainability, especially in Indonesia. And what do you think, how to improve such investment in Indonesia? Maybe two questions first, and then we will go to the next question. Please, Professor Rashid.
Yeah, so thank you very much for the questions, and they're very important and topical because many people are interested. For example, between pollution, climate change, and overfishing, which I guess is the policy part of the question, right? So ineffective management of our ocean. At the moment, from our work and my reading and my conversation with colleagues, at the moment we believe that overfishing through ineffective management is the biggest threat to fisheries. Why? Because it is the one that directly takes fish out of the ocean, right, at the moment. Now, climate change is an indirect effect. The ocean is warm, you move, or acidification, deoxygenation, and then pollution is also indirect. But the fear is that in not too distant future, climate change will overtake this, because as the ocean is warming and acidification is increasing, that impact could actually overtake that of ineffective fisheries management, for example. So that is what I understand at the moment. Now, investment, very important. That's the finance part. And your question actually was part of the reason we first go about identifying what are the barriers and then working through. Now, for Indonesia, and I think you're alluding to also developing countries in general, you know, and there we stress a lot about capacity building and just training people in finance and investment and insurance, actually, you know, how to do that in the private sector. But we also stress a lot the enabling environment, because this is important. Like, if you did take all the investment needed in the ocean economy, you can categorize them into three groups. One, you have ocean economic activities that are very profitable. They can compete in the market. And so for those ones, you don't need to worry. The private sector will go in because they make money, right? So that's easy. And you can talk about agriculture, and some fisheries, right, are very profitable. Now, there are other types of investment where the returns for business is actually lower than the market return. They give you return, but not that big. And this is because there's a lot of non-market values, right? The society, we want nutrition, we want to feed people, and we want to maintain the ecosystem. So there, I think partnership between the public sector, philanthropy, and the private sector is important. because then the gap, we have to fill that gap, and that comes through philanthropy and the government sector. Now, there is a third group where you don't get any return at all. It's valuable, it's all on market, you cannot monetize it, and there we just have to have public and philanthropy to finance what we need to do to protect the ocean. All right. There's a lot of activity here in developing countries, actually developing instruments to help it do it. So, yep, in the paper and the report. Thank you.
Thank you. I think that is very clear. And comes to the next question, still for Professor Rashid. What is your perspective about the region which has the conflict of interest, such as in Southeast Asia and in Indonesia? We have some region that have a conflict of interest. How to sustainably manage and solving this issue?
Yeah, that is tough. And I think the question, the person mentioned the South China Sea as an example, right? So this is a conflict area, high level politics. Right?
Composition. So this is the background of our research. Before this research was done, the study about the composition.
Sorry, anybody? Would you please unmute? Okay. Can you unmute your microphone? Okay.
So when you think of the South China Sea, it's a lot of politics, it's a lot of high-level conflict. You know, you have China and all the countries, what they're doing. So those are difficult to manage because you need collaboration in order to manage these joint systems, because many countries have the right to fish in the South China Sea. Now, the way I've seen this solved around the world is actually for the nations to say, okay, there's all this politics. You can go and do your politics, but for the sake of our fishing communities, for the sake of food security, you take our fisheries out of this big fight. We manage the fisheries well. And I can give you an example. Norway and the Soviet Union, even at the height of the Cold War, there was all that fight between Soviet Union and the West, but Norway and Russia and Soviet Union at the time managed to cooperate to manage their cod stocks in the Barents Sea. It's quite beautiful, right? So it's really trying to package your problems, put them in boxes. You know, I mean, we fight on some things and we cooperate on some things. And I think that's the way to deal with those kind of areas. Yeah. Thank you.
Thank you. And the last two questions, I will read it together, these two questions from Dr. Riza. Can you explain what is the confidence level on the decline of the fish resource in the tropics? And also the last question from Pak Swadi. Would you please advise few example about the solution example to closer to the achievement of ocean sustainability through the finance?
The finance, yeah. All right, so the confidence interval, this is a lot that my colleagues, stock assessment people really work on. And they are all estimates, you know, and they usually will build confidence intervals around that. What I can say about that is from all the numbers I've seen, sometimes there is a bit different. Some say the bill fishes or tunas are down by 90%. And some will say by 76%, right? So you'll have a range, but in general, it's down, right? So the way I deal with it as an economist, I say, even if half of the estimate, only half is correct, the decline is still substantial. So you got to do something, you know. So it's my pragmatic approach to this. But I'm sure a stock assessment person will be able to answer that a bit more precision, right? And
look at me, look at me, look at me. Look at me.
Sorry. Committee, can you
This is real life. That's good. So, and the second question is about, what was the second question again, please? Sorry. The second question is, can you remind?
The second question is about the example. The example of, wait a minute. Few example about the solution which closer to the achievement of the ocean's sustainability through finance.
Yeah, through finance. I think one of them, there are many ways you can look at this and answer this question. But I really think one of the key things, one of the ways to do it is to look at all the funding, public funding in particular, philanthropy, foundations, that goes to support the ocean. We look at that and make sure that those monies are used to support sustainability and fishing communities, right? Why do I say that? When we look at subsidies, for example, $35 billion is the estimate, global subsidies. 22 billion of that is classified as overfishing subsidies, fuel and buying engines for people. They go to take the fish down and then make it harder for people to catch fish next time. So if you can redirect this subsidy to, for example, train people, and even support activity. For example, in Germany, they say, we will use our subsidies to pay fishers to fish for plastic rather than fish. So you have a system which is overfish and there's a lot of marine debris. You will use subsidies to pay people to go clean the fishes. So they give the fish a break, they get their livelihood, which we all want, and the fish come back, so we get better food and more jobs for people. So that's the kind of ways we can create funding that will then create the environment for private sector to really move in and also make money in a sustainable way. Yeah. All right.
Thank you very much, Professor Rashid. So this is the responsibility for all of us, not only the government, also private sectors, and also the community.
Community, absolutely, yeah. We all have a stake in this. You can't sit back and say only government. Government doesn't do anything until we tell the government to do something. So, yeah.
Okay. Thank you very much. Yeah. Now we move to the second presenter. Some question has been delivered. So from Pak Alim, Professor Elinda, would you please explain, or is there any predicted economic loss due to the sea lice outbreak in Philippines? And also, is there any fish species which can be used as biocontrol to control the sea lice invasion in the tropics? And also the second question, is there any simple way to overcome the infection of the sea lice in fish? Please, Professor Erlinda.
Okay, I hope you can hear me clearly because we're having very strong and heavy rain since last night. Okay. And I had to mute my microphone so it will not be a disturbance to whoever is talking. So,
it's clear.
And I am thankful that I did not had any power failure issues or connectivity issues. So thank you. Anyway, going to the first question is there a predictive economic analysis or cost
economic loss
for the sea lice infection in the Philippines? Well, I'm not sure about the other countries, other members of the ASEAN region, but in the Philippines, we have many small-scale fish farms, and most of the time they do not report their losses or mortalities. So it's really very hard to get figures for the economic losses. That it could be done, but it will require cooperation of the farmers or the operators of the facility, and of course with the help of the social scientists. Perhaps it will be beneficial, no, to include that in the, at the end of my presentation, I gave a list of potential research areas that could be taken up. So maybe we can include that there. But sadly, it's very difficult to get the economic analysis of this, no, because of the issues that I have presented. And then the second question is, what was that?
Biocontrol.
Okay. If you look at the literature in EU or Canada and other countries, they have been using wrasse and lumpfish for biocontrol, no, as cleaner fish. Now in the region, in the Southeast Asian region, I have not seen any published report on that, but there are anecdotal reports, no, on the use of fish or cleaner fish as a biocontrol. In fact, when I was still in CIFDEC, I used to remember that we were using wrasse as control against leech infection on grouper, I should say, on grouper broodstocks. The problem with using cleaner fish like wrasse is its availability, because they had to catch or collect wrasse from the wild. So if you do that, if the practice is intensified, then we might be encountering supply problems, or issues. So that is one. Okay, and for other countries like Indonesia, maybe I did not see any published literature or report on that. And then the other question is on
is the simple way to overcome infection.
I wish I can give you a concrete answer, but if you look at the Lepidopterus salmonis infection, no, in EU and other in Northern America, they have been studying about sea lice control for 4 decades now. But still, it's still a big problem. So I wish I have a concrete solution to that, because we are experiencing that, as I have presented in my presentation, earlier in the Lepidopterus spinifer infection on pompano broodstock. It is perennially occurring. So we do all sorts of treatments like regular freshwater treatment, but still, after a few days, infection again is an issue. So it's a continuous problem. So I wish I have a simple solution to that.
Okay, so still need research to overcome the problems.
Yeah.
And there are still some questions for Professor Erlinda. In your opinion, what is the factor that is affected the level of pathogenicity? Because some of the species affect the mortality or cause the mortality, but some they don't cause the mortality. So what is the factors? And the second question is the identification of a species of sea lice is very important. And what is your suggestion for the methods of identification? Is there any molecular-based identification that is enough and reliable enough for identification?
Okay, as to the factors that affects pathogenicity, or why some species are pathogenic or most are non-pathogenic, well, I think that should be a good news to us. Otherwise, if all species are pathogenic, then it the problem is aggravated. So if you remember my presentation, I gave only about maybe 5 species that we should look into. And I think the number one factor there is the specificity of the sea lice species on the host, or its host specificity. Epidemicus it has very low host specificity, meaning it can infect any kind of host species. And other one will be the distribution of the sea lice species. Epidemicus is widely distributed. It has been recorded in I think more than 30 countries, causing disease problems and mortalities. And then the ability of the sea lice species to transfer host, its mobility. It can switch to any host species that is within the surroundings of the sea lice species. I think those are the 3 most important factors that affects the pathogenicity of the sea lice species. And then as to the identification, if molecular tools will be applicable, I think it is, but maybe you can call me a traditionalist or a traditional parasitologist or conventional parasitologist, but I think for parasitology, still the gold standard should be morphology. I'm sorry to say this. I know we have many young students, researchers with us now, and they really like to do molecular studies. Yes, it is helpful, but in the case of parasitology, I still believe that you have to look at the whole morphology of the parasite to be able to do the accurate identification. Of course, molecular identification or molecular tools is also accurate, but in the case of parasites, I think we should still consider morphology as the gold standard. Okay, thank you.
Okay, thank you very much, Prof. Erlinda. Now let me move.
Any other question that I missed?
I think that is, I have read all the questions for you.
Okay, thank you.
Thank you. Let me move to Professor Sutawat. Several questions delivered for you. The first one, I will read the 2 first questions. In generation of hydrolyzed collagen, that will be a waste of fat or lipid. Can we use this lipid waste for another utilization? And also another question is there any other technique to remove the fat other than the vacuum impregnation technique? Please, Professor Sutawat.
Thank you so much for the question. Actually, we want a zero waste concept. So it means that it's a good idea to utilize all the things. And you know that, like fat from the skin, also from the flesh itself, the rich in the PUFAR, which is good for health, actually the EPA or DHA that we have been known. So from that one, we can use to like other supplement as well. You can see from the market that there are a lot of fish oil, krill oil, shrimp oil, and now we also work on shrimp oil as well. And we found that they're rich in PUFAR. But one thing that you have to deal with is you have to do purification to lower the fishy odor, undesirable or odor of smell. And then you have to come up with the way to just protect them from oxidation, further oxidation, like you have to put in capsule, or you have to put together with the tocopherols, our vitamin E, for example, so they are packaging together. So that's very important thing. Otherwise, those kind of the oil that you recover can be like a deterioration by oxidation process. Okay, so, and the second question is other technique that we use. Of course, you have, because this one is kind of like lab scale, and we need to upscale also for like applications. But we also have other technique, to just like maybe remove the oil after hydrolysis. But that oil basically dispersed uniformly is kind of emulsion. So you will have to break down emulsion to separate the oil from the hydrolyzed collagen. I mean, the liquid you mentioned, that hydrolyzed collagen, I show you one picture. And those kind of fat is kind of distribute like an emulsion. So your challenge is to collapse the emulsion and make the fat release from the hydrolyzed collagen. So you have to use combined techniques together to just effectively remove those kind of oil. Otherwise, after you have even like a small amount of the oil or fat in the hydrolyzed collagen, especially in the dry form. You can imagine the dry form is mean a huge surface area, and the air going to contact directly with the fat. So it's undergo oxidation much easier. So that's why I focus on how to defat the either for in raw material or finished product as much possible. Okay.
Thank you very much. Another questions for you. Is there any difference between freshwater fish and seawater fish skin in terms of the functional properties? And also another question is, what is the advantage of using the skin byproduct compared to other byproduct from fish? We have another byproduct like guts and other thing. And what is the advantage of the skin compared to other byproducts? And also the last question is how to maintain the stability of the collagen when you apply it in the fortification for a drink.
Okay. All right. Actually, we are also starting to use like some freshwater fish like a night tilapia, because we can culture it. So easy to just like get and ensure the quantity that we can use for production of collagen in terms of industrial scale. Because now I would say that once we have the COVID, those kind of industries closed, and we have problem with the raw material. That's true. So that's why we have to just like ensure that, okay, we have to have the contact farming that can provide us, those kind of skin continuously. That's very important. But in terms of functional or bioactivities between those two, I mean, between the freshwater one and also the marine one, we never compare it, but they have a lot of literature using the night tilapia as or maybe like carp as a raw material. But I myself think that, okay, basically, the collagen itself, they have like a similar sequences, but the most important thing that how to produce it, what kind of enzyme that you use it. For example, if you use trypsin, they have the specificity in cleavage of peptide, and you end up with the peptide with different sequences, amino sequences, and those different sequences of the amino acid gonna determine the bioactivity. As I show you some slices, right? Because that's very important to determine. So now we can, if you want to like synthesize the peptide with high activities, we have identified first what is the sequences of the peptide, what the size of peptide. That can be achieved by develop the process, appropriate process to end up with that one. Okay, so I would say that you can use both freshwater and marine fish skin as raw material just to exploit and fully utilization of the skin, which is byproduct. Okay, it's clear for the first question. All right, and the second question is advantages of the skin when compared with other leftover like a scale, bone, okay, or swim bladders or internal organ. One thing that, okay, compare with this scale. Actually, scale in Thailand, we import the ozone. We call ozone. Ozone is demineralized scale. It's kind of bulky, okay? And then the processor or manufacturer, they can hydrolyze it, but they get very low yield when compared with the skin. This kind of obviously see that the skin provide much higher yield when compared with when you use bone or a scale. That thing that very important in terms of economy. Also, we have to think that when we produce something, we have to get higher yield. All right, but they still have limitation for skin. Like as I mentioned, as I give a talk that fishy odor that very is kind of drawback. So we need to just like go further and develop the process that you can implement it easily for industry. And that's very important. And you see that in Indonesia also, you go to visit the fish processing industry, a lot of a large amount of skin generated. So I myself, I think it's kind of it's advantageous to use the skin rather than the scale or bone. Bone also, you have to do mineralization process, you see, and you can see in the bone, they have collagen together with calcium hydroxyapatite. We're also working on that one as well. But we see that in the bone, they have collagen, but small amount. So you have to add the extra process, demineralization process. You see it's costly also. So that's why I prefer skin, but still challenging for us to just improve the quality as well as fishy odor. All right, is this okay? And the last one is what? To maintain, okay. To maintain the bioactivity actually in the drink, right? When we fortify it. So I think it depends on the material inside. But when, for example, the one will be, we show you that about the drink that you can see the decreasing of the activity during as a function of time. That because some reaction take place, during the storage. So one of them is a Maillard reaction. You can see the darker in colors. And once a Maillard reaction occurs, it means the N-terminal is gonna, amino group gonna link together or bind together with carbonyl compound, anything that they have carbonyl group. So this kind maybe leads aggregation, some aggregation and the loose activities. So I think we can lower the loss in activity by keeping in the cooling temperature like a refrigerator. But anyway, the purpose of this sterilized product is mean that we want to keep in the room temperature, right? And easy to transportation without the keeping in a low temperature. So, but if you want to like, clarify somehow, you have to put in that one to lower the reaction. But of course, it's not spoiled by microorganism because all this microorganism is kind of killed by sterilization process. But like freezing, chemical reactions still take place. Even though you see in the sterilized drink, still have some reaction take place that lose in the bioactivity of the collagen, but it's not too bad actually. So they have some limited time. So maybe like a industry or manufacturer can say the expiry date is when something like this. Okay.
Okay, thank you very much, Professor Sutamat. So ladies and gentlemen, I think we will almost reach the last part of this session. We have been going through a very insightful presentation in various topics of marine and fisheries, start from the ocean economics, and then we move to the fish parasites, and we move again to the fish skin hydrolyzed collagen. So I will not make any conclusion for this session, but I hope that this incitement will bring you new idea for your scientific perspective. I will take this opportunity to send my sincere gratitude to all of our speakers. I will give a big applause from here, maybe from all the audience also for all the speakers. Thank you very much for your kindness, sharing your experience and also your expertise with us. Thank you very much. And I will give this time back to the MC. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Very much, Ibu Indun, for leading the session, and also to the speakers for delivering such informative presentations. Ladies and gentlemen, those are the agendas we have presented to you this morning. Now, we would like to take a documentation of this event. So we request for participants to please turn on your cameras if you don't have any connectivity difficulties.
together.
So the all participants, please kindly turn on the video so we can take a photo together. Okay, to the first slide. 1, 2, and 3. Then the second slide. 1, 2, and 3. To the next slide. 1, 2, and 3. To the fourth slide. 1, 2, and 3. And the next one. 1, 2, and 3. And the last one. 1, 2, and 3. Thank you.
Terima kasih.
Thank you, Professor Rashid. Thank you, Professor Sutawat, and thank you, Professor Elinda.
Thank you.
You all, thank you.
Rashid. Nice to meet you again.
Pleasure.
Thank you very much.
All
Thank you
right.
so much.
Very much. Thank you, Paul.
Good night to you
Thank
from
you very
Vancouver.
much.
Thank you.
All right. Take care.
And
Okay.
Thank you. Thank you very much. Now, before we close this opening ceremony, we have a little announcement. We will have a short break before we enter the parallel session that will take place at 1 o'clock. We kindly request for participants to please return to this meeting room again 15 minutes before the session starts. Ladies and gentlemen, we have finished the plenary session today. I am Retno Yulifenia as the MC today, and I sincerely apologize for any inconveniences that may have occurred throughout this event. Thank you very much for all your participation and your attention. And please enjoy the symposium.
Bye.
Thank you.
Thank
you very
you. Bye.
thank you.
Thank
all.
you, Prof. Erlinda. See you this afternoon.
Thank you
Thank you,
also.
Prof.
Okay, I will
Sutawat.
try to come
Bye-bye.
back.
Bye-bye.
Okay.
Yeah.
Bye-bye. See you
Bye.
later.
See you.